hand first. Right. So what you're looking on at the screen right now is the course plan, yeah? So for the course plan, for last week, practical, we did not manage to do because of the Chinese New Year public holiday, okay? So last week, we should have been doing this topic, yeah? Connecting physical layers / exploring internetworking devices, and then identify MAC and IP addresses, right? So based on the course plan, this week we should have been doing this, examining the ARP table. So remember ARP table, we discussed this during the lecture, yeah? And configuring initial router settings. So we start to prepare ourselves with router configuration, because after that, we'll be looking at, we start to look at IP addressing in our lecture. We move on to network layer already, next week. So this morning, we're going to cover the topic that we postponed from last week. Okay, we're going to cover these two. Okay, connecting physical layer, exploring internet networking devices, and identify MAC and IP addresses. And for tomorrow morning, we'll continue with this, examining the ARP table and configuring initial router settings. So when we do this, hopefully by next week, we're back on track, yeah, for the practical. Okay. Right. So we'll start to record our session. Right, so you guys will follow with me, okay? So there are two packet trace activities this morning that we're going to look at. So I'm going to touch not in detail, but enough so that you guys can continue doing it. The first one is this one, 4.7.1, connecting physical layer. And after this one, we will do on this one, 9.1.3, identifying MAC and IP addresses. Okay. Right. So before that, we do this. Please open your own version on your own computer. You follow, and let me get the packet tracer activity notes. Right. So what is the objective? I will try to maybe put it at the side so we can see like that. Yeah. Right. So there are four objectives here, divided into four parts. Okay, first part, we want to identify physical characteristics of internet networking devices. Obviously, we don't have a physical devices, but we have a representation inside this packet tracer. Okay, so there are images connected to each of the devices, so that means we can actually look at images like later we'll see as we go through the sections. This will hopefully train you a little bit on when you are looking at the real hardware in the subsequent course after this course, yeah, when you actually can hold in your hand the hardware. The next course after this will be computer networks. Okay, computer networks we actually have an opportunity to work with the real devices, right? So part one, we want to identify certain characteristics of the internet networking devices. Okay, internet networking devices meaning routers and switches. Yeah. Then next, we're going to select correct modules for connectivity. Now, in the real world, we'll not be having opportunity to do this. Correct modules means if you don't have specific backplates, yeah, because usually it's very modular. The devices on the market from Cisco, very modular, in the sense that it allows when you buy devices from Cisco allow you to buy the basic product, and depending on how you scale up, you upgrade your network, then you can purchase. You have a few choices, modules for specific brands, sorry, specific model, that you can buy the modules that you can install at the backplate that will upgrade. Okay, you upgrade the model that you already purchased. Okay, usually when you scale up your network, you want to add certain facility or certain more ports, things like that. Yeah. So we're going to look at that in part two. Okay, here we can simulate it, right? So in the real world, you probably go and purchase the modules, and you can basically place it at the backplate of your device. Right. Part three, as you can see on the topology there, only some of the media is basically connecting those devices. So part three is your job to connect all the devices that you see. Okay. As usual, after you connect devices, you will check connectivity. Right. Okay. So this is the background. Okay. In this activity, you will explore different options available on internetworking devices. You will also be required to determine which options provide the necessary connectivity when connecting multiple devices. Finally, you will add the correct modules and connect the devices. That simply means that there might be certain devices here which do not have the necessary ports. Okay, so you try to connect the media, it may not work. So because there's no port for the back. So this simulator allows you to choose have a choice of modules that you can choose, and you have to choose the right module to place at the backplate of your device so that you have that port, right? So that's part of the thing that you have to do, yeah. All right, so again, it's a combination of automatic checking here, auto marking here, right? When you're doing the activity, some parts of the question is a direct question, so you might need open your word processor, right? Microsoft Word, maybe, yeah, for you to record your answer. Okay, so we go to step one from part one. Identify the management ports of a Cisco router. So I'm just gonna put it side by side, right? If you're a larger monitor, will be easier for you, yeah. Okay, click the east router. So try to locate the east router. You can see that this from the network representation, this is a router and it's called east. So click on that, right? When you click on that, what you see is something like this, right? So you can use the zoom feature to look at it more closely, but to tell you that the image is not very high resolution, so you sometimes you can't really make out the labels, but you can guess lah. You can guess what it is. So you want to enlarge, you can enlarge the window. Maybe it can help you further to zoom in like that, yeah. Right. So, but mine I'm going to keep it small so I can also refer to this, or maybe just make it big. Right. Okay. So you're looking at the backplate of this router, and you can see very clearly the model name is Cisco 1941 series. Okay. So, and then you can see that there's a backplate here that is empty. Okay, so allowing you to basically drag and drop modules. Okay, different modules provide different capability. So by default, the first module is selected, and for that module, you can see description. Okay, you can see here the HWYC-1GE-SFP is single wide, a lot of acronyms, yeah, with one small form factor pluggable SFP slot, and it's it goes on to describe what are ports available. You can see Cisco copper, optical gate, on port, all this, yeah, and small image here representing the backplate. Okay, where you can place it, right? So and then you can click other modules available, and it will show you the description will change depending on which module you click, showing you the different options. Okay, so basically, if you want, you can just drag and drop here. All right. Now let's go back to the activity. All right. So it says here, zoom in and expand the window to see the entire router. Which management ports are available? You can see this here. Okay, so it's definitely not the Ethernet port. It's definitely not so management ports. Okay, from the keyword itself, you know, management ports means it's a port that you can connect to perform management on the device. So have a look at that. Okay, and identify management ports. Okay. I'll give you a hint. There are two management ports there. One that you're very familiar with. One we didn't use before. Okay, right. You can see. I can see that the label is very clear. Okay. From my screen, I can see it. Right. So answer those questions. That question, which management ports are available? Next, identify the LAN and WAN interfaces. So this one, it makes your job easier if you understand that for local area network, what kind of cable normally is used, and for wide area network, what kind of cables normally you use, because the cable determines the interface that you can connect it to, right? So when you identify, count how many of them of these the interfaces, wide area network, and how many are the LAN interface that you can plug in. Yeah. All right. You try first. Later, if you're still not sure, you can ask me. You can let me know. Then I'll help you. For now, you try first. Make a guess. Okay. All right. Okay. Next. Okay. Click the CLI tab. We're now at the physical tab. So CLI tab, the command line interface tab is here, and immediately you see the where you can actually type the command to do or some settings inside. Right? Press enter key and then type the command. We already know how to enter. Right? Enable. We are in here. Okay. And it says enter the following commands, which is show IP interface brief. Okay. So show IP interface means the interfaces that is available. So show IP interface brief. Just provide brief details. Okay. Right. So how many physical interfaces are listed? Okay. Physical rather than virtual. Can you see which one is the virtual one? All right. So very easy to see what's the virtual. It starts with V, right? Virtual LAN. That's virtual. So we don't count those as physical interface. Physical interface usually has a corresponding interface at the back plate. So if you check it out here, you can see that there are 2, 3, 4. So four physical interfaces there. So enter your answer. Right? So now we want to, if you want to see a particular interface only, so command is show interface gigabit. Now you can type the full name, gigabit Ethernet example. Okay, because it's given there. Don't forget, you want to know which interface, not gigabyte, okay, gigabit Ethernet, right? So you can type that, okay? Hmm, oops. Sorry, there's a thing I really make a mistake there. Okay, and then it'll show you more details about that specific interface. Usually, you can also get by with doing this. Just G, right? And it shows you the same thing. Okay? So G stands for gigabit. Usually, for the fast Ethernet, is normally it can be represented in short form by FA. Okay, so you have fast Ethernet and gigabit Internet. From the name, you know, gigabit will achieve 1,000. I think it's 1,000 megabits per second. So 1 gigabit. Okay, and but it's not necessarily 1 gigabit. It could be 1 gigabit and above. Okay, so fast Internet usually range at the 100 megabits per second. So you know that gigabits will be faster, right? So from there, if this is a router, right? So you have to choose, yeah, which interface you want to connect. If you want to connect to switch, okay. Always remember that switches, when if you want to provide very good speed on the network, the switches try to, if you have the ports available on the switch, try to connect the fastest port on the switch to your router. Because remember, all the end devices in your LAN will be sharing that link between your switch and the router, especially if all the end devices want to communicate outside of the LAN, right? So you can see how you can see the command show IP is the internet protocol, right? Show IP interface brief to show you very briefly how many interfaces you have, and then narrowing down to individual interface, okay, by using the command show interface and then the name of the interface, right? So the question next is asking what is the default bandwidth of this interface. So once you are here, you have to know how to basically find information, okay, information here, right? So which one would be the bandwidth of the interface? So you already have a guess, yeah? Should be a big number because this is gigabit, right? Have you found it? Yeah, you'll be right if you say this is the one that is in kilobits per second, yeah?
Per second.
Right? And that should be equivalent to, that is tells you the media type is RJ45. It's a full duplex capable of this interface is capable of full duplex communication, and of course as you will start to see a lot of the information is actually meaningful to use as we go through the through our lectures, yeah. Okay, so for example, full duplex, you know what it means. right? You know what is RJ45. You know, basically the speed, okay? And starting from next week, you'll start to know more about the internet addressing, right? And I think you, because we covered it, you start to know what is ARP already, yeah? Okay. All right. So, write your answer. Next, we want to have a look at the serial interface. So we want to type, just follow the, what now? Activity show, interface, serial. You can type the serial or just put S. Okay. Right, so now you're looking at the serial interface. You can even see that it says it's down and line protocol is down, so it's disabled. So it's in the shutdown mode, yeah. But it's already configured with this internet address, yeah. So note that if you don't understand the slash slash, the prefix, don't worry. Something from next week lecture you'll start to see, but it's enough to know, okay, this already pre-configured with the this IP address for this particular interface, right? And you can start to see that the speed is slower, right? But I want you to also notice that the MTU still the same, so there's no fragmentation needed for your frames, right? Okay, so what is the default bandwidth? You can see that, slower, right? It's typical. We always say that. But anyway, this is serial cable. Of course, it's going to be bandwidth. It's going to be slower. So that's why we always say that the LAN speed is faster than wide area network speed. Okay. All right. So let's go to the next. You've answered that. What is the default bandwidth of this interface? Right. Bandwidth on serial interface used by routing processes to determine the best path to a destination. It does not indicate the actual bandwidth of the interface. Actual bandwidth is negotiated with the service provider. Okay, this is simulated, So in the real world, you have basically have no idea, okay, because it's beyond your control. Anything after your home router, okay, is beyond your control. You can only control within your own LAN, okay. And if you're having a home network, even for business, if the business didn't get this line, right? So anything beyond the router, what kind of speed, well, is all depend on the provision given by the internet service provider, right? Okay, so and they're not sure whether they're forthcoming to tell you what kind of media they use or what kind of bandwidth they have. Maybe you can, if you have the opportunity, you can ask the technician that comes to provide the connectivity to you. Sometimes they will say, sometimes they won't, sometimes, but most probably they know lah, right? But whether they're forthcoming with the information, the one not depending on the technician, but the point is that the actual bandwidth we don't know. Okay, you can look at your interface speed, but the interface speed also depend on the other end, right? And sometimes the bandwidth is shared, okay, especially for the ISP point of view, provide the bandwidth to be shared among the customers in a location, right? And sometimes it's also based on your tier, your customer, what kind of product you purchase or you get from the ISP, whether they control your speed or not. That's all on the ISP point of view. Okay. Right. So now we go to step 3. We want to identify module expansion slots. Okay. How many expansion slots are available to add additional module to each router? So for this, we go back to physical tab. Right. How many do you see that you are able to put in? Okay, so you can drag and drop. You can drag one module, put it in. Normally, you will have to switch off first. This is switch. This is the power switch of the device. You have to switch off, drag, or else you. I think, if I'm not mistaken, if you just drag while it's switch on, there will be an error. And then if you want to try again, okay, so you put in one module, try to get another module, and then you'll confirm whether if how many modules it can support, right? Okay, write your answer. Go next to go back here for the next question. It says click switch to. So look for switch to. Can find it here. Just click it. How many expansion slots are available? Let's zoom in. Right? How many?
One.
You can try. Right? You can try drag and drag. Switch off first. Drag. How many does it allow you to be sure? Right? Okay. Write your answer. Okay. Always, if you're able to test, always test your theory, your answer. Okay. I'll let you to investigate that. Okay. Right. So that ends our part 1. Let's go to part 2. Okay. Very easy to test. To test, switch off the device and drag and drop modules onto it. How many can you fit in? That will tell you for sure, right? And see whether your guess is correct. All right. Step 1, determine which modules provide the required connectivity. So here you make use of the information given to you. When you click on the modules at the left-hand side that I've shown you earlier, okay, and read the description, see whether you can pick from the description, you can pick the right module, okay, when you want to connect. When you want to connect, you know what cable to use, okay, the physical cable to use. And when you use the physical cable, you know what kind of connector you have to fit into the port, right? So from there, you can basically read the description of the modules, whether it can provide that port or interface. Okay, so that's how you basically figure it out now. You must know before you figure out what interface to use. You must know what cable you're going to use as the media. Okay, that's that's the step lah. Important is what cable you can use, what cable is suitable to use. Then you find the module that provides the interface, the type of interface you need. Okay, so click is. Okay, click is. Click the physical tab, is already there. On the left, beneath the module labels, you see the available options. These are the available options, and these are the description. You can basically increase it like that. I can I can view easily, view more easily, right? So maybe I can do this like that. Yeah. Okay. You click lah, and you read the description. See whether you can understand what is the capability of each module. Okay, there's a picture, there's description. Okay, try to get used to it. Okay, number 1, you need to connect PCs 1, 2, and 3. Where is it? Just above the east router. PC 1, 2, and 3. Okay, but you do not have the necessary funds to purchase a new switch. Okay, so That means you want to connect, you're desperate, you want to connect these three PCs, but you don't have money, okay, to buy a new switch. Maybe you have enough budget just for module. So in order to connect these three PCs to the east router, which of these modules do you think is suitable? So first of all, you know that you need to use what kind of cable, because remember, when you try to connect devices together, you have to look at both devices' capability, and normally the capability is minimum. Capability is based on the minimum of the device. That means which device you, even if you want high speed, but what if one of the device is not high speed, so you need to lower down your expectation. So first of all, you before you choose what modules to put on the east, look at what the PC is have available. Okay, and then we just want to buy modules for the router, not on the PC itself. Okay, right. So we basically only have this type of connectivity. There is only one, right? Only one. Okay, so if you go here, you know there's only one interface, which is the fast Ethernet. So that means what? What do you guys think? We're not buying anything for the PC. We're buying the module for the router. So we want to connect the PC directly to the router because we don't have enough budget to buy another switch. So we want a cheaper option. We want to buy module we put on the router so that the PC can connect to the router directly. But again, because we're not buying anything for the PC, we have to use what is already available on the PC. So when we look at the interface on the PC, right? Can you see? We only have the fast Ethernet, right? The Bluetooth, of course, is not meant to use for networking. So not in the sense that we want to use here, it's too slow. And also it's wireless also, right? So fast Ethernet. Okay, so that means that gives you an idea already when you're looking at the physical module here that you want to put at the back plate. Okay, there are two things immediately very obvious. You need to be able to cover at least 3 PC. And each PC, that means 3 interface, right? You need to have 3 interface minimum. And those interface must be fast Ethernet. Can you see the how I arrived to that conclusion? Because well, our requirement is we need to connect 3 PCs. Then my second requirement is that I cannot do anything about the PC network interface, so we have to follow what the PC has, which is fast Ethernet. So look at the module description. Which modules provide you with that? Can you guys check now? Okay, the first one, it says copper gigabit. Okay, gigabit out, optical out, right? Okay, so let's look at the second one. Serial out. We don't have serial. Okay, cable. We don't need serial. What about this one? It says 4 switching ports, and it gives you that. Okay, I think we found what we want, but let me make it bigger. But let me see others. This one console port, no. This one just a cover. This one smart grid switches, nope. So I think it's this one, right? Let me zoom in. So you see what I mean? If I drag this one, cannot, power is on. So do what it says, switch off first. You can see the LED become gray. Now drag it, put in, okay? And then don't forget, once you put in, turn back the power on. And you'll see that the tree start booting up. So it's trying to emulate what actually happened in the real world. But of course, in the real world, it's not that fast to boot up. I've seen it. Okay, it's not that fast, but it will boot up, right? Once you switch on. Okay, so also this is better electrical hazard. Okay, so you remember in the real world when you want to add a module, you plug and play, but still there's electric current. So to be safe, switch off first. Okay, and then attempt to add the module in. Once you satisfy it's attached securely and safely, then you switch on the power. Okay. All right. So write down the answer, which module it is. We actually went through all, and then we selected HWIC 4ESW. Right. So we know we need 3, right? Because PC1, PC2, PC3. But how many ports do you see? So very obvious, right? How many ports?
4.
Yes, 4. So that means one extra, just in case you need you have another PC coming in, right? That's good. All right, so let's continue. It says B. Yeah, we go to B now. Click switch to. All right, we close this one. We already added. Oops, sorry. We added. Now switch to. Which is switch to here. Okay. Place it here. Okay, which module can you insert to provide a gigabit optical connection to, oh, that is switch 3, isn't it? Which module? Oh, yeah, okay. So that means you want to connect switch 2 to switch 3 using a gigabit capable cable, so which is fiber, basically, because it says, which module can you insert to provide gigabit optical connection? So very easy, very similar thing that you need to do. Go to the module one by one, see which one can you put in here. You just need one, right? Yeah, A. So one. You just need one. Which one provide you optical, gigabit optical? Let's go and click. Okay, this one is ISDN. Okay. This one is one fast Ethernet. Okay. No, we don't want that. That's fast Ethernet. And gigabit Ethernet copper. Well, we want fiber, right? This is copper. This one. Again, fast Ethernet interface for use with fiber. This is fiber, but it's fast Ethernet. Is there any more? Gigabit, provide gigabit optical. Ah, yep. Because the next one is cover. So luckily this one match. Right. So again, zoom in, switch off. Right. And then we drag that gigabit optical connectivity. So all right, that sounds the right one. So take it and put it there. Right. Look, it's already you already have it this one, but never mind. We add one more. Okay. Let's look at switch 3. Actually, does switch 3 has it? Yes, it says 2. Okay, good. Right, so done for switch 2. Okay, so So far, okay? You guys following, yeah? I
Yeah.
think now you know you can plug and play modules. Not really plug and play because you have to switch off your device first, but you get the idea, yeah? Usually buying modules is cheaper than buying the entire device. So if you have a, if you can, this is what I mean by scaling up your network. That means you want to grow your network, so you might want extra ports, and to decide which one you want, you need to know what you want to connect it to and which cable you want, right? So again, very important. The capability you seek for is basically the minimum, uh, or I would say the minimum capability you want is what is the lowest device capability you have. Okay, find the device. If you have many devices you want to interconnect, choose the lowest capability device and check what is requirement, and that is your upgrade choice. Okay, because you cannot choose the best if one of your device is not up to the capability lah, right? Especially if you cannot upgrade that device, right? So we move on to hang on, yeah, step 2. Click is an attempt to insert from modules are added by clicking the mode. Okay, we've done that already. Okay, we did this already. Actually, we're supposed to just wait, just choose first, right? So to remove, you chose the wrong module. Just drag it out. Okay, drag it out back to the module options, and then it will be removed. Okay, so we did for switch for the router is, we did for the switch 2 as well. So now it says go to the switch 2 and oops, it's not this one. We want this one actually. So go to it's clear there. Enter the tree, okay, and show IP because we already switch on, right? That's why we can see this tree. So we just want to see. Oops, show. Right. So now we can see the what we have done. Oh, the other one is actually fast Ethernet. What we added is the gigabit Ethernet. So now we've added, so we have the gigabit Ethernet capability for switch 2, right? So in which slot was it inserted? Oh, okay. The slot I use is slot. You can see there because I put it at the end, right? So that's why. Oh, sorry. That was this one. That was the 3 was the original one. The one we inserted was this one. Always remember for fiber, you will see 2. Okay, so let's go back to the physical. I was a bit confused. This is 3. This is 5. And remember the fiber optic cable. One cable is send, one cable is receive. So you need 2 cables to have full duplex. So the 2 here means it's part of one cable, but the one cable is split into 2, one for sending, one for receive, or you can have full duplex communication, right? So this is the one that you basically connected. Okay. Right, so move on to part 3, connect the devices. Select the appropriate cable type, click the first device. If you're not sure, you click on the device, check the backplate or check the play, show IP interface brief, see what port it has, and then if you have that port, then you're okay with the cable, right? So here, this table is already given to you, right? And the cable type already specified for you, and which interface to connect. So device to device, east router to switch one, the interface on the east router, you should choose gigabit Ethernet 0 and use copper straight through, connect to switch one, interface gigabit Ethernet 01. Okay, so I'll do the first one with you guys. So let's go back to this. Okay, so we want copper straight through. So click the connection icon, copper straight through is here. Go, click on it, go to the east, click on the east router, select, there's no, yes, there's gigabit Ethernet 00, click on that. The other end, you want to connect to switch one is here, okay, and then click on it, select gigabit Ethernet 01, so this one, okay, and you're done for that segment. Now, I will let you do the rest, okay, let you do the rest, yeah, just follow what I did earlier on. Choose the interface, choose the cable, click on the device, choose the interface, click on the second device, choose the interface. Make sure you choose the correct interface. Is that okay?
Okay.
Okay. Right. So once you do that, once you complete all those connectivities, then of course we want to test, right? Check your connectivity, say part 4. Right. So once you do on the east, of course the east not complete yet. You need to connect the PCs, connect the switch, connect the west. I'm pretty sure of this. Just check your table, right? And for part 4, go back to east, go to the CLI, right? So I'm just gonna make it a bit bigger. And that maybe I can do also. Show IP interface brief. Okay, so don't forget, just now I went in, but it may not be up. Okay, what do you need to do to get it up? Let's say if it's down, you need to go to the specific interface and bring it up by typing no shutdown. Okay, but if you see that it's down, yeah. If not, if you check here, or it's up, all those that you have made connection, then should be okay, right? So I only connected one, right? So this might not be all correct lah. When we guys already connect all the needed connection, then your show IP interface brief on the east router should be like this. Says if all the cabling is correct, the output should match. Mine should not match because I didn't do everything, connected everything. Right? Okay, you do that. Make sure everything is okay. Step 2, connect wireless device, laptop, and tablet PC. So let me just close this one and go to, where's my laptop? It's down here. Yes. So we have the access point here. Okay. And our wireless LAN consists of that and the tablet PC and laptop. Click the laptop, select config, select wireless 0, put a check in the box label on, which means there will be connection happening. So let's do that. I'll do that one for you. Okay. And go to the config, select wireless, switch on, disable, make it bigger. Okay, here, port status, click on, okay, and it should start to, yeah, you can see the connectivity link, okay. Let me, then you go to desktop, click the web browser. Okay, I'm not going to do that because it's not going to be successful because my access point is not connected to the switch yet. You guys will do that. So I'll just show you how to do it for the laptop. You might need to do for the tablet as well. Okay. All right. And then go to, once you, what you want to test here is web browser. Type this address, Cisco PKA. It's one of the server that has a web server, web services turned on in pretty sure it should be server is somewhere there. Okay, although it says DHCP server, it should also have the web service running. Okay, so step 3, change the access method of the tablet PC. Select the tablet PC. Select config, select wireless, uncheck the box level on, and the connection will drop. Click the 3G 4G cell, this one. There's a cell tower provision here, you can see that. So tablet PC right now is let's say it's connected to access point. So you want to use the LTE connection, the cell connection, right? Put a check on the to the port status. Cellular connection should appear. So it will connect to the cell tower instead. So you go here, you config wireless off it. It's on. When you check here on, it connect there. Off. Go to this one, switch it on, and when you switch on, it should connect to the cell tower. You can see there. But do this step by step. I'm just skipping some of the things you guys should do step by step. Okay. All right. Then check connectivity of all the other PCs. Go to all the PCs, ping each other. Okay. If you can ping each other means PC to PC. You can perform the test, verify all the connection. Okay. To check connection to the server, do the browser like this, and then you can see the web page load up. Then you know connectivity is fine. Okay, right. So that's it. I went through very briefly. I went through skipping certain things. You guys should don't skip anything. Okay, but I want you guys to have the opportunity to explore yourself. So that's why I left some of the configuration to you, especially the media. Okay, choose the correct media. Follow this table to provide connectivity to this topology. Okay, any question?
No.
No,
So far, no.
Okay, all right. Okay, so I want to move now to the second packet tracer, which is 913. Okay, if you don't have any time to do right now, you can continue doing. I hope you log in using your name. Okay, earlier on to the packet tracer so that you can save your progress. Okay, or you want to practice first. Later, you get a idea about it. Choose a contiguous time of your own, and you can go do straight straight do. You can do this as homework as well if you're not enough time here. All right, let's have a look at this 913 packet tracer. Identify MAC and IP addresses. Okay, so let me just choose. I think it should be this one, right? Okay, so these exercises in this packet tracer just now was about media, about connectivity, connecting wired, wireless, fiber, serial, and cell towers. The cell towers basically is how it represents how your, like, for example, your phone connect to the radio signal from the cell tower. Okay, normal cell tower. So that was about that. Okay, this activity is about MAC and IP address. So here we want to investigate the usage of the MAC addresses and IP addresses in the network. Okay, So here, it will be the first time I think you will use the simulation or simulator part. Okay, right now we are using real time. If you notice at the bottom right corner, real time, to view the PDU, the packet data units, you need to switch to simulation mode. Very easy. Click simulation mode, then this thing appear and the network will run in simulation mode. That means it will do very slowly that for you to test. If you click on this one, means it's step by step like debugging. Okay, so before that we go back to real time and go back here. Okay, so here the objective part one, gather PDU information for local network communication. And then the second part, you do the same thing, gather PDU information for remote network communication. Okay, remote network means between LANs. Local means within the LAN. Okay, so this activity is optimized for viewing PDUs. Again, PDU stands for packet data, protocol data units, not packet, protocol data units. So that means if you open the PDU, you can see at every layer what is the PDU you can see inside. So that's good. What's good about packet tracer activity, you can actually do those things. So you will gather PDU information in simulation mode and answer a series of questions about the data you collect. So there will be questions here. Please answer in a separate, use another Word document, name it based on this packet tracer activity number. So it's easier for you to revise later. All right. Let's look at the part one, gather PDU information from local network communication. Right, review the reflection question in part three before proceeding. So let's go to part three. Where is part three? Any part three? Oh, not part three. It's just reflection question here. So that you'll be prepared what question will be asked of you. So while you're doing the part one and two, you will observe. Since you already know the questions, you will observe, you will pay attention into specific areas while you're doing that so that you can know to look out for the answer to the questions. So let's go very quickly through this. Were there different types of cables media used to connect devices? Okay, I think you know because you've been doing exercise from the previous one. You know you can identify cables. Did the cables change the handling of the PDU in any way? Right, based on our lecture earlier on, which PDU information will change if you change from one media to another media? Can you still recall which layer, and which PDU the header information might change if you go from different type of media to a different type of media? Any guess? That relates to question number 2. Did the cable change? Cable change means from one segment to another segment, the media change. That means the media change, the cable change. So if you know this, the answer I asked, then you know which PDU you want to look at, because it says here, handling of the PDU in any way. All right. So keep that in mind. All right. Number 3, did the hub lose any of the information that it received? Okay, so later when you're tracing the PDU movement, you want to pay attention when it's entering the hub and leaving the hub. Okay. Number 4, what does the hub do with the MAC address and IP address? So when you check out the PDU, check the MAC address at the frame and IP address at the network level PDU. Okay. Did the wireless access point do anything with the information given to it? Again, if you change to the segment where it's using wireless, okay, media, check the content of the PDU. See any difference once it entered the wireless or from the cable, right? Was any MAC or IP address lost during the wireless transfer? And check it out later. What was the highest OSI layer that the hub and access point used? Okay, does it match with your theory knowledge? We know that hub is a what layer? Hub is a device at which layer from theory? Layer what? Noel, your answer?
Two.
Hub. From theory, yeah, hub is layer 1 actually. Okay, Noel? Layer 2 is switch, and then layer 3 is router. Okay, that's from our theory, from our lecture. Hub is layer 1. It does not know anything about MAC. Okay, so what was the highest OSI layer that the hub and access point used? So later when you are tracing through the simulation mode, I want you to have a look. Okay, whether any information when it's reached the hub, whether there's any information higher than layer 1 for the PDU at the hub, and also check when it's at the access point. Okay, so here, because the simulator here follows very closely the details of the real networking, but here you can basically trace, okay, the movement of the PDU when it's moving through the network, so you can see what's happening at each point, and you can use this to see your theory knowledge and what actually happens. Does it match? And if your theory part is not so good, you can see here what actually happens. Okay, so this can help you with that. Did the hub or access point ever replicate a PDU that was rejected with the red X? Okay, so in the simulation mode, when you see a red X, the PDU is actually rejected. So the question is asking, did the hub replicate the PDU? That means if there's a PDU with X, is there another copy that the hub creates? Okay, so check it out later. Taking note of that question. When examining the PDU details tab, which MAC address appeared first? The source or destination? That means look into the PDU frame. Which one is in the first location? Is it the source or is it the destination, or is it the opposite? Okay. Why would the MAC address appear in this order? Okay, this one is critical thinking. Think about it. Okay, if this is the source, then why is it the source at the front? Or if it's a destination, why is the destination at the front? Okay, this is critical thinking question. Okay, reason it out and give an answer why you think. If you're not, if you guessing, okay, try to find answer whether it is true. If not, we can discuss it later. Okay, put a note there. Okay, want to discuss with lecturer. Okay, put a pin. If you're not sure about your answer, was there a pattern to the MAC addressing in the simulation? And is there a pattern? I'm sure you're very curious why the pattern is there. Did the switches ever replicate a PDU that was rejected with the red X? Every time that the PDU was sent between the 10 network and the 172 network, the beginning of the network, the address, there was a point where the MAC addresses suddenly change. Where did that occur? So that means you have two networks, 10, the network starting with 10 and the network starting with 172. If there was a point when the MAC address suddenly changed, when the PDU travels between the networks, where did that change occur? Okay, please take note of that. which device uses MAC addresses that start with 00D0 colon BA? It starts with that. Of course, it's longer because 48 bits, right? But which device use that MAC address? Find that out. 15. What devices did the other MAC address belong to? Right? Okay. Did the sending and receiving IP version 4 addresses change field in any of the PDU? Right? When you follow the reply to a ping, of course, when you are generating traffic here for testing, you're using a ping. Huh? When you follow the reply to a ping, so send the ping, you see the ping travel to the destination, and then the destination will reply. Okay, that's what we mean by reply ping. When you follow the reply to a ping, sometimes called a pong, ping, pong, right? Do you see the sending and receiving IP version 4 address switch? Switch here means at first source is this, destination is this. When the reply is sent out, did it change? This source becomes destination, destination becomes source. Okay. What is the pattern to the IP version 4 addressing used in this simulation? Why do different IP networks need to be assigned to different ports of a router? Okay, again, this one is a critical thinking. Why? Why different ports of the router assign different IP networks? Okay. If this simulation was configured with IP version 6 instead of IP version 4, what will be different? Again, this is the critical thinking. Okay. Right. So keep in mind those questions that you need to answer. It will take some time for you to notice, and some of the question you have to think about it first before you answer. Right. Let's look at gathering here. Part 1 first. Gather PDU. This is local network first. Right. So click at 172.16.51.5 and open the command prompt. So I imagine the names 172.16.51.5 ping 172.16.312. So okay, so click here. You know how to ping. Go to desktop. Go to command prompt. Type ping. And follow what was requested. I think it's this one. So ping, give it the address given 172.16.31.2. Press enter. So you can see that the ping works. There's a reply from that 172.16.31.2. So let's see. The point 2 is this one. So it did not. We know this is local. Why? Because it's in the same network. How do we know in the same network? Because we don't have to. It still belong in the same interface of the router. Okay. If we have to cross the router to go to that device, then we know we are doing remote. If we don't have to cross the router, then this router becomes our gateway from this perspective, and also from this other network perspective, that is also the gateway, right? So we are pinging in the same network. Okay. Now switch to simulation mode and repeat the ping. Okay, so let's go to simulation mode. So I'm gonna just open this one, repeat the ping. Okay, so stop there because simulation mode. Okay. A PDU appears next to 172.16.31.5. So we see that PDU, that's the PDU, that envelope looking icon. Okay, but when you use ping application, the protocol the ping application use is this ICMP. Okay, that's why it says type ICMP means when this PDU that looks like envelope is a PDU, protocol data unit, and the type of that PDU is the ICMP type, which is ICMP protocol or ping protocol, right? That's what it means, yeah. All right. And then click the PDU and note the following information from the OSI model and outbound PDU layer. Outbound means going out, inbound means going in. Okay, so let's click on the PDU. I'm just gonna put it there. Do that, right? So click the PDU, right? This is what you see. And notice that the OSI model and outbound PDU details. So OSI model, let's have a look at it once. Okay, and note the following from OSI model and outbound PDU details. So we note this, what we can see. So you can see the layers there. Okay, so for ICMP protocol, there's only up to layer 3. Okay, so let's look at outbound PDU details. So here you can see it's the opposite way. So Ethernet, we have the IP, okay, IP PDU, and also the ICMP, right? So you can see, remember the fields for Ethernet 2, preamble, destination, source. You can enlarge this so you can see it nicely. Just remember for the Ethernet 2 is a frame. So this is a frame. Okay. And then for IP is this PDU is belong to network layer, which is that means this is a packet. This is a packet. Okay. Right. And then the ICMP is basically the message that you want to send, right? Yeah. So the data basically is the ICMP message, right? So let's go back to this one. Sorry. Okay. So click the PDU and note the following from this. And destination MAC address is check now. Should be that. Okay. You're pinging, right? You're pinging in the same network. So it's destination MAC address inside your own network. The switch, remember, will use the switching table, the MAC address port table. So the destination MAC address will be the destination, will be the MAC address of the destination end device for its NIC. And the source MAC address should be the origin, okay, that computer's MAC address. And then even though it's in the LAN, of course, at the network layer, we also have the source IP address and the destination IP address, right? Okay, so let's have a look. Set model. Okay, so we have three layers. Okay, we know that source IP address is that, destination IP address is that, because we ping from .5 to .2, right? And then let's have a look at outbound. Outbound, look at the frame. Okay, this is the destination MAC address. This is the source MAC address. And then we look at the IP, the network layer PDU, source IP address, destination IP address. Okay, that's what it asks us to notice, right? Click capture forward, the right arrow followed by vertical bar. Means you just want to move one step. So go back to here, not here, this one. And then I close this one first. This one, yeah, that button. Capture forward, one step. So click on that. Okay, so it moved one until switch, right? Okay, that's what good about simulation. You can trace it step by step, right? Now it says gather the same information from step 1D just now. check out the same thing and find a notepad and write it down somewhere, or can put in the Word document. Just this is your observation. Okay. Right. Repeat this process until PDU reaches its destination. So basically, just click step. Right. Every time it pause, record the PDU information. Okay. Now, okay. It says use a spreadsheet. You can either use Google Sheet or you can use Excel. Okay. You can copy paste this one, or you can use it in your Word. You copy paste this into your Word, right? And then you can extend. For example, let me just open my Word. And if I go here, copy this, go here, right? You copy that, and then if you want to add one more, just sorry. You're here, just press tab. And so if you don't see the lines, just go to here and just say select all borders. Okay, select all borders, and then you can adjust the thickness of the border later. Okay, just do that. Right, then keep on adding if you want more, keep on adding to it. Right, just tap. Right, so let's go back here. Gather additional PDU information from other pings. Okay, so because now after you gather that one, it should reply, and then you fill up the information at each point, right? At switch, hub, and then return back, and then do the same ping from 2 to 3. Create another table, fill it up, and then from 4 to 5. Okay, 2 to 3, 4 to 5. Because 4 to 5 use switch, 2 to 3 use hub. So is there any difference? And if you capture all the information at each step, you should have a clear picture what's happening, and that will help you to answer some questions over here, right? So before I move on to the next part, just complete. Remember, when you do this, check the PDU, get the information, fill up the table. Okay, so it goes to hub, then it goes to what happened here. Now I want you to understand my question earlier on. Hub is a layer 1 device. Hub is not like a switch. Switch is layer 2. Switch knows MAC address. Hub does not know. So if hub does not know MAC address, it will not open to see the destination MAC address. So it still needs to deliver it. So what can hub do? A hub will broadcast. Okay, so there's another 2 ports on the hub. It will not broadcast back to the incoming port just now. Just broadcast to the other 2 hub port it has. Okay, if it has more, it will broadcast to all. But the X there means when the ICMP packet reach the destination. Okay, once 172.16.31.2 opens up to the network layer, it sees the IP address destination. It matches its own IP address, so it will accept. Okay, no X means the end device accepts the message. Whereas with the X means when that 172.16.31.3 receive that packet, it will open up the encapsulate until layer 3 network layer. It will then take the destination IP address and compare with its own IP address. It doesn't match, so it knows that doesn't belong to it. Okay, that is at the ping level. But at the MAC level, it can check the destination MAC address. Okay, the destination. In fact, if it doesn't even reach the network layer, if it checks at the MAC address, it compares. Then it's not even its own MAC address, the destination MAC address, so it will reject the frame. So X means it rejects, but I need you to see the rejection is at the frame or the network layer. This will lead you to answer the questions at the bottom. But of course, the one that match, okay, want you to see match MAC or match IP or both, and then it will return back a reply. As you can see, because hub will always broadcast. This is the thing with layer 1. It doesn't know MAC address, so it doesn't know whether this in this port or this port. So as the reply reach the hub sends one to here as well and one to this switch. You just saw that happening. This is what actually will happen in the real world if you use hub. That's why hub is not that efficient, right? But switch knows. So when the frame reach the switch will know which port. It will send back the reply. And what will you see? You will see here, there is a reply. And a ping will, when you see four reply here, means there's 4 ping. And the ping will get the time, so you can see the average. Okay? All right, so there you see that there's a tick, blinking tick means, okay, if the ping successful, because the initial ping received the reply. Okay, right? So that's what you're tracking. So at each point, you will fill up the table. Okay, from the table you can actually use the information in the table to answer the question. Right. So that's local network. So now we want to try to do part 2. Okay, we want to involve the router because router connects networks together. So this is one network, this is one network. Just also remember when it's to note what's happening when it change the media. So here you can see this one is definitely serial. This one is straight through. But then this one is Wi-Fi. So please take note. The question also asks about that. So when you're noting down the what's happening, take note from there as well. Right. So again, we want to do what will happen. Okay, when we send a ping to a remote host. So here is the one that we can ping from 5 to 02. Okay, open the command prompt on the 5, click ping, but now you ping in this laptop 10.10.10.2. You can see that this is a 172 network, this is a 10 network, right? Then ping, right? Let's see. Will it work? Go back to real time first. Okay, go to here. Okay, so it runs a ping now 10.10.10.2. The request timeout is because it hasn't learned the path yet. Once it learns the path, you can see that reply is okay, right? All right, so successful. Now we want to do it in simulation mode. Go to simulation mode, do the same thing. Okay, ping, and okay, I just go there, ping. Okay, it's gonna stop because you can see there, right? Then you can again do the same step as before. Step. Okay, you expect it to go there, because, well, it's in the different network. It goes to the default gateway, which is the router. So it will go there, and it will go there, and it will go there, and it will go, should go there, right? Trace through it, okay? And don't forget, when you're tracing, you fill up this table, different table, okay? Right, take note of this. Basically, you are doing the same thing, but now it's for remote. Once you complete both, you have all the gather all the information, then you start to do the reflection question. Okay. Any question?
So far no.
No, all right. So do you guys know what to do? You should do the first. If you're not complete the earlier packet tracer, do the earlier packet tracer first. Okay, and then after you finish that, then go to then you can start doing this one. Okay.
Okay.
Right. So I think all of you know how to proceed for both of the packet tracer. No question, then I'll let you do. Okay, I'll let you do, and I'm monitoring our chat, and also I'll be monitoring you guys. If you encounter any difficulties, let me know. Okay. But now you can proceed. You can do the first one first. The other packet tracer, complete that one, and then you can attempt this one.
No.
All right. Okay. Right. I'm gonna stop my recording now. Okay. Any question? Just let me know. Yeah, guys.
Hello.
Hi. So, how's it going with the
Uh,
exercises? Okay, yeah. All right. All right. So we run out of time already. Yeah, 9:30 to 11:30. So, I'll see you guys tomorrow morning.
Okay, sir.
Okay. All right. Have a good day.
Okay, sir.
Bye.
Thank you.